Assalamualaikum. We are from Group 3 Discrete Mathematics Section 6. We will be presenting about problem-based learning group task.
For our group members' roles, Nadia does the methodology solving using the Prim's algorithm, Wawa does the mathematical solving, Fasha does the methodology for the question 2, Sufia does the problem statement, and Sharmila does the methodology solving using the Kruskal algorithm.
Problem statement. For this project, we are focusing on two main problems. First, an electric utility provider needs to connect several substations, but each possible connection has a different cost due to factors like installation difficulty and capacity. If the network is not planned properly, it can lead to higher costs and inefficient power distribution. So, the main challenge here is to design an optimal transmission network that connects all substations while keeping the total cost as low as possible. Secondly, we look at how a computer operating system organizes files using a directory tree. Without a clear structure, managing and accessing files becomes difficult. Therefore, we need to analyze and represent the directory structure using tree concepts such as parent nodes, child nodes, and leaf nodes to ensure efficient file management.
Now, let's move on to the methodology section of our project. To solve our network problem, we are focusing on two primary greedy algorithms, Kruskal and Prince. First, Kruskal algorithm is a greedy approach used to find the minimum spanning tree, or MST, of a weak undirected graph. We focus on adding the shortest possible edges to the network while ensuring no cycle form. First algorithm. Though it follows a different step of step, it's also a greedy algorithm designed to find the MST. It's particularly effective for dense graph. In the next slide, we will take a closer look at the specific steps involved in executing Krebs algorithm. Krebs algorithm. Though it follows a different step of step, let's break down the 7-step process for Krebs algorithm as is applied to a power transmission network. Step 1. Initialize structure. We model a power network as a weak undirected graph which each substation is a vertex and the possible transmission line are edges, with weights representing the installation cost. Step 2. Selection of starting vertex. We begin by choosing any substation at random. This single vertex becomes the starting point of our minimum spanning tree. Step 3. Edge selection. From our current tree, we'll add all the edges connecting to substation outside the tree. We then selected the edge with the minimum cost. Step 4. Expansion. We add the selected edge and the new vertex to our MST, effectively growing the connected network. Step 5. Cycle prevention. The key benefit of Prims is that cycles are automatically avoided because we only select edge that connect our tree to an unvisited vertex. Step 6. Iterative process. We repeat steps 3 through 5 until every substation is included in the tree. Step 7. Termination. The algorithm ends once the MST contains all 7 substations and 6 edges. This gives us the most cost-effective power transmission network possible.
In this slide, I will explain the step-by-step process of Kruskal algorithm, which is used to find a minimum spanning tree in a weighted graph. First, we start with sorting the transmission line. All the edges in the graph are listed together with their weights, and then they are sorted in the ascending order from the smallest to the largest weight. Next is the initialization of sets. At the beginning of each substation or vertex is placed in its own disjoint set. This helps us easily detect whether adding and edges will form a cycle. After that, we will move to the edge selection. We choose the edge with the smallest weight from the sorted list and check whether adding this edge will create a cycle. This leads to cycle prevention if the selected edge connects two substations from different set. The edge will be accepted and added to the spanning tree. However, if it connects vertices within the same set, it will not be accepted to the spanning tree. Then, in the union of set step, when the edge is added, the two sets connected by that edge are merged into a single set. Finally, we reach the termination condition. These steps are repeated until the spanning tree contains v minus 1 edge, where v is the number of vertices in the graph. At this point, the minimum spanning tree is completed.
So, I would like to explain about the methodology for question 2. First, we analyze the directory tree structure. For the parent node, we identify that node X parent is download because node X is directly located under the downloads directory. Next, for the children of node 2, which is document, the children are study and personal since both nodes are directly under document. After that, we identify the leaf nodes in the directory tree. The leaf nodes are picture, video, voice, Excel, assignment, and certificates because these nodes do not have any children. Then, we determine the degree of node 1, which is study. The degree is 1 because it has only one child, which is assignment. To convert the directory structure into a binary tree, we use the first child next sibling methods. In this method, the first child is placed as the left child, while siblings are placed as the right child. This allows the hierarchical directory structure to be represented efficiently in a binary tree while maintaining all parent-child relationships.
Okay, now I will present about mathematical working. For question 1, we are given graph that represent an electrical network. Our goal is to connect all the nodes with the minimum total cost. This is called a minimum spanning tree. For the first one is about Kruskal algorithm. We select edge starting from the smallest weight and avoid forming any cycle. The selected edge have weight 10, 12, 14, 16, 20, and 25. When we add them together, the total cost is 99. The second one is about for Prim's algorithm. We start from one node and keep connecting the nearest node step by step. Even though the order of the edge is different, the total cost is also 99. So overall, this shows that both Kruskal and Prim produce the same minimum total cost, even though they use different approach. Now is about question 2, which is binary tree. For question 2, we build a binary tree based on a folder directory structure. A binary tree means each node can have maximum of 2 children, a left child and a right child. The main folder, main, becomes the root. Downloads and document are the children of main. Inside download, we have media and office. They are siblings because they are the shared parents. The parent is the nodes above, the child is the node below, and siblings are nodes that have the same parent. If the question asks to arrange the nodes in alphabet order, that will be a binary search tree. But this question we only follow the given directory structure.
In conclusion, this assignment shows how theoretical algorithms such as tree structure and minimum spanning tree algorithm can be applied to solve real-world problems, particularly in data organization and network optimization.